notation. So you probably done this before in science. This is usually where you see a lot. When we're working with really big numbers or really small numbers, we use scientific notation just so you don't have to write all those zeros in there. So scientific notation is used in dealing with your very small numbers or keeping track of the place value. It's difficult just because there's so many zeros. Okay, so a number is expressed in scientific notation when it is written as a product. What does product mean? Multiply. So when we're multiplying two things, we're multiplying a factor, so just a constant, just a number, and a power of 10. Okay, so this factor must be greater or equal to 1 and less than 10. Okay, in other words, we can look at it and it looks something like this. Okay, where we have a some number times 10 to the something power. Okay, where the something power that's in has to be an integer, has to be a whole number, positive or negative number, and an a has to be between 0 and 10. For example, this one would be in scientific notation. Notice that we have a 6.59. Okay, this number in front of the decimal place has to be greater than or equal to 1, but less than 10. We go up to 9, but we can't go past 9. Okay? So this is saying the 4 means to move the decimal place 4 times. Okay? So in this case, the decimal is starting here, and I'm going to move it 4 times. They go 1, 2, 3, 4. And in these little dips where I don't have anything, we put zeros. So we end up with 65,900, because I'm adding 2 zeros after it. This is all review. I'm assuming you've done it before, right? Alright, so in our next example, this would be in scientific notation. Again, notice that we have just one number in front of our decimal place, the 4. In this case, since we have a negative 6, this means that we're going to move the opposite direction. Instead of moving the decimal to the right, we're going to move the decimal to the left 6 places. So to put it here, I'm going to go 1, 2, 3, 4, 5, 6. And all these little dips, we're going to go 1, 2, 3, 4, 5 zeros and put our decimal place right there. It is nice. Alright, so steps to express a number in scientific form to standard notation. So scientific is when we have the times 10 to the something power. Standard notation is just the full regular number. So this one and this one would be our standard form. Up here is our scientific. Okay? So first we're going to figure out if n is greater than 0 or less than 0, meaning if it's positive or negative, which way are we going to put the decimal place?
Positive, it's on the right, it's negative, it's on.
Good, yep. So if n is greater than 0, it's positive, then we move to the right. And if it's less than 0, negative, we move to the left. Then so number 3 is to add our zeros. We have a little loop there. We put zeros and then put our decimal place and with the commas wherever they are. Okay, so this one. This tells me to move our decimal place which direction? To the right, because it's positive. 8 times, right? So we're going to start here, go 1, 2, 3, 4, 5, 6, 7, 8. So how many zeros are we going to have to add here? 6. 1, 2, 3, 4, 5, 6. Remember, commas go after every 3 places. Okay, example B. Which way are we moving the decimal place? To the left. Where is the decimal place?
It's just 3.9.
Right, 3.9. So it's right behind the 3. So we're going to move it to the left 5 places. 1, 2, 3, 4, 5. So here's my decimal place. When we have such a small number, there's nothing in front of it, I want you to put 0 point. right? Otherwise, if you just want the point, whatever, it's hard to tell where your decimal place is, so make sure you put the 0 in front. And your decimal place really big, it's fat, so you can tell where it is. And then how many zeros are we put in front of the brain? 4. And in this case, remember when we're working with decimals, you don't worry about commas. Pretty much. Yep, going back and forth. So now we're going to take standard form, a quote regular number, and we're going to put it into scientific notation. This maybe is a little bit difficult. I don't know. It's not really that difficult. It's just a little bit different thinking than going from the scientific to the standard. But it's the same thing. Just moving backwards. So first I want to move the decimal point so that it is to the right of the first non-zero digit. Okay, so that's our A. That's the number that we're going to take times 10 to the whatever. And if you move the decimal place to the left, we're going to say whatever that number is after we move the decimal place, A, times 10 to the positive 8. How many places do you move the decimal? But if you move it to the but if you move it to the right, then you're going to end with a negative because it's going to be a decimal like little tiny guy. Okay, writing out the steps doesn't make a lot of sense. It makes more sense when you actually do the problem. Okay, so where is my decimal place in this first one? In front of the 3. Okay, that's where we want to move it, right? Because right there. Yeah, but you're right. We want to move it right after. So how many places do we have to move it to get it there? Okay, so 1, 2, 3, 4, 5, 6, 7 places.
So it'd just be 8. It'd just be the 3.05 times 10 to the 7.
10 to the. Because we moved it 7 times.
Could it be 305 times 10 to the fifth?
No, because in scientific notation, remember this number has to be between 1 and 10. Good thing to point out about here. Okay, how about on B? How many places do we have to move this in? 4. 1, 2, 3, 4. You're right, it's going to be negative. So times 10 to the negative 4. What's our number out front?
Something like 1.
Okay, so we often see large numbers in the media, where you're using a combination of a number and a word, such as 3.2 million, like in newspapers or magazines. They usually write like that. Since Wright's number in standard notation, remember the quote regular number, we're going to rewrite the word million as, well, let's say million has how many zeros? 6. So write this into the 6. And it says as exponent 6 indicates the decimal which you move 6 places to the right and belong to the millions place. Alright, any questions so far, thanks? Awesome. Alright, sample 3 is a really nice little chart there. It says the graph shows the chocolate and candy cane sales during a recent holiday season. Express the sales of candy canes, chocolates, and all candy in standard notation. Okay, so candy canes is down here, this little guy. If we want it in standard notation, we have to take 120 million and put it in standard notation. So million means we're going to do what? Times 10 to the 6. Yep. So if I write it like this, is this in scientific notation? Why not?
It could be smaller.
Okay, it could be smaller because this number in front isn't between 1 and 10, right? Right, so we need to move the decimal here. But they wanted it in standard notation first. So how are we going to take this number and write it in standard notation?
Wouldn't you get to look 2 places to the left?
No, because I want to quote regular number. I don't want to add 6 zeros. Yep, so we're just going to take the number and then add 6 zeros. 1, 2, 3, 4, 5, 6.
Or really, you could just look at a million at 6 zeros, so 120.
So, would we write the top one at the bottom?
This is our answer.
This is what I'm still on me, right?
This is the one that's standard. This is the standard or standard notation. Standard notation is like the quote regular number. Okay, chocolates. Chocolates is 300 million. So notice I'm not including these 2 zeros that they give me at the beginning. I'm adding 6 more after it. Okay? And then candy is 1.45 billion. So billion is how many?
Yes.
So in this case, I have to think about moving the decimal 9 places. So I'm really adding how many zeros? 7, because I'm already moving it twice. And then adding 7. 1, 2, 3, 4, 5, 6, 7. Okay, is anybody confused by that last one? Very good. Okay, then it asks us to write the scientific notation. Okay, so candy canes. Remember, we threw it at the beginning here as 120 times 10 to the 6th. So if we were going to take that, if I just started with this one, and put it in scientific notation, how could I change it?
Maybe 1 point and add 1.2 times 10 to the 6.
Okay, how do we know it's 8 and not 4?
Because you have to move it all the way to
Exactly. Because if we think about it, we could look at this one. And I can think, okay, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. So I would probably think more of the times 6 and then add 2 because we're moving it 2 more places. But if it makes more sense for you to write out the zeros first and then think about it moving it that way, whichever one makes more sense to you. Okay, and why didn't I put this 0 there?
You don't need it. So that's the only doesn't matter.
Right, the end of the decimal, it doesn't matter. So yeah, okay, good. Chocolates. Over to go.
3 times 10 to the 8.
Yes. And all candy.
1.5 times 10.
Times 10 to what?
9.
So we do time, yeah, 9 times. Very nice. Okay, any questions on those? Example 4 says evaluate this thing. Express the result in scientific and in standard notation. So there's 2 answers, one in scientific and one in standard. So what we're going to do first is we're going to multiply the quote regular numbers on the outside. So what is 5 times 14.5. And then we're going to say times 10 to the, and remember when we're multiplying, I should probably do something. Okay, so then if I'm looking at this one, if we're multiplying these 2 numbers, what are we going to do with the exponents? Add them together. So what's negative 8 plus 2?
Negative 6.
I have 2 to the negative 6. Now, is this one in scientific notation? No, it's really close. How do we change it so it's in scientific?
So it doesn't move with 1 with that.
So is it going to be 10 to the negative 5, or should it be 10 to the negative 7?
Negative 5. 7.
How can we be sure? If we're not sure, what can we do to check our answers to see if we're right? Write it out. I would take this guy and just put it in standard. How would we take this guy and put it in standard form?
14.5 and 6 places.
Okay, so we would go 1, 2, 3, 4, 5, 6, right? So we'll put some 3 there. So 1, 2, 3, 4. Okay, so for this one, how many places do we have for this next one? 1, 1, 2, 3, 4, 5 places. So should this be a 5 or a 5 or should it be a 7? Okay, you see how I went from one to another to check your answers to see? Okay. Do we understand why it's a negative 5 and not a negative 7? Okay. When in doubt, you can always check by plugging it in here. I mean, you can take the original up here and type that into your calculator. As long as you type it in right and you come up with this, then you know that you're okay.
In doubt, write it out.
I'm sorry.
If in doubt, write it out.
Yeah, definitely not right now. Okay, now what am I going to do on this next one? Good, so it's going to have to tell me more.
It's like into that point.
Okay, so we're taking these regular numbers on the outside and we're dividing them. 0.245 times 10 to the, what are we going to do?
Just take
And you minus x to the 4. Good. Is this in scientific notation?
No.
No, not quite. Close. What are we going to exchange it? Good, we're going to move this guy over, right? So is it going to be 10 to the 5th or 10 to the 3rd? Good, 3rd.
Because you're moving
Okay.
to the
I guess 4.
How can we check?
Write it out.
I don't write it out. Because I honestly, I always think really hard about it. I think it's just easier to take this guy and say, okay, this means move it 4 times. 1, 2, 3, 4. Add that 0. So in order to do it, you go 1, 2, 3, 4, right? So should it be to the 3rd? I miscounted, it's fine. I was like, why doesn't that work? Because I actually did these in there. 1, 2, 3, 4.
You're going to the 2 point, right?
Oh, yeah, because I wanted to. Goodness gracious me. I was really afraid of it. Okay, yeah. Got it. Okay.